Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Data Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
You have a data stored in BigQuery. The data in the BigQuery dataset must be highly available. You need to define a storage, backup, and recovery strategy of this data that minimizes cost. How should you configure the BigQuery table that have a recovery point objective, RPO, of 30 days? The options are: Option A, set the BigQuery dataset to be regional. In the event of an emergency, use a point-in-time snapshot to recover the data. Option B, set the BigQuery dataset to be regional. Create a scheduled query to make copies of the data to tables suffixed with the time of the backup. In the event of an emergency, use the backup copy of the table. Option C, set the BigQuery dataset to be multi-regional. In the event of an emergency, use a point-in-time snapshot to recover the data. Option D, set the BigQuery dataset to be multi-regional. Create a scheduled query to make copies of the data to tables suffixed with the time of the backup. In the event of an emergency, use the backup copy of the table.
To arrive at the correct answer, we focus on the keywords: highly available, minimizes cost, recovery point objective, RPO, of 30 days.
The correct answer is option C, set the BigQuery dataset to be multi-regional. In the event of an emergency, use a point-in-time snapshot to recover the data.
Why is this correct? C. Multi-regional datasets provide high availability. Point-in-time snapshots minimize storage costs because you only pay for the data that is changed, unlike scheduled queries which create full copies. Why are the others incorrect? A regional dataset does not provide the required high availability compared to a multi-regional dataset. B. A regional dataset lacks high availability, and scheduled queries create full table copies which significantly increase storage costs. D. While multi-regional provides high availability, scheduled queries duplicate data and fail to minimize costs compared to point-in-time snapshots.
You used DataPrep to create a recipe on a sample of data in a BigQuery table. You want to reuse this recipe on a daily upload of data with the same schema, after the load job with variable execution time completes. What should you do? The options are: Option A, create a cron schedule in DataPrep. Option B, create an App Engine cron job to schedule the execution of the DataPrep job. Option C, export the recipe as a DataPrep template and create a job in Cloud Scheduler. Option D, export the DataPrep job as a Dataflow template and incorporate it into a Composer job.
To arrive at the correct answer, we focus on the keywords: reuse this recipe, daily upload of data, after the load job with variable execution time completes.
The correct answer is option D, export the DataPrep job as a Dataflow template and incorporate it into a Composer job.
Why is this correct? D. Cloud Composer orchestrates complex workflows with task dependencies. Exporting the DataPrep job as a Dataflow template allows Composer to trigger it exactly after the upstream load job with variable execution time completes. Why are the others incorrect? A cron schedule in DataPrep runs at fixed times and cannot coordinate with or wait for a preceding load job that has a variable execution time. B. App Engine cron jobs execute on fixed schedules. They are not suited for orchestrating dependent workflows where the preceding job has a variable execution time. C. Cloud Scheduler triggers jobs based on a fixed time schedule, lacking the ability to dynamically wait for the completion of an upstream job with a variable execution time.
You want to automate execution of a multi-step data pipeline running on Google Cloud. The pipeline includes Dataproc and Dataflow jobs that have multiple dependencies on each other. You want to use managed services where possible, and the pipeline will run every day. Which tool should you use? The options are Option A, cron. Option B, Cloud Composer. Option C, Cloud Scheduler. Option D, Workflow Templates on Dataproc.
To arrive at the correct answer, we focus on the keywords, multi-step data pipeline, Dataproc and Dataflow jobs, multiple dependencies on each other, managed services.
Correct answer is option B, Cloud Composer.
Why is this correct? B. Cloud Composer is a fully managed workflow orchestration service built on Apache Airflow. It excels at managing complex multi-step pipelines across various GCP services like Dataproc and Dataflow, easily handling intricate dependencies. Why are the others incorrect? A. Cron is an OS-level scheduling utility, not a managed Google Cloud service, and it lacks native features to handle complex pipeline dependencies. C. Cloud Scheduler is an enterprise-grade managed cron job scheduler. It is designed for triggering single tasks or events, not for orchestrating multi-step pipelines with dependencies. D. Workflow templates on Dataproc are limited to orchestrating jobs strictly within Dataproc environments and cannot natively manage dependencies spanning across other services like Dataflow.
You are managing a cloud Dataproc cluster. You need to make a job run faster while minimizing costs, without losing work in progress on your clusters. What should you do? The options are Option A, increase the cluster size with more non-preemptible workers. Option B, increase the cluster size with preemptible worker nodes, and configure them to forcefully decommission. Option C, increase the cluster size with preemptible worker nodes, and use Cloud Stack Driver to trigger a script to preserve work. Option D, increase the cluster size with preemptible worker nodes, and configure them to use graceful decommissioning.
To arrive at the correct answer, we focus on the keywords, Cloud Dataproc Cluster, Job Run Faster, minimizing costs, without losing work in progress.
The correct answer is option D, increase the cluster size with preemptible worker nodes, and configure them to use graceful decommissioning.
Why is this correct? D. Preemptible workers minimize costs while expanding the cluster to run jobs faster. Graceful decommissioning ensures running tasks finish before nodes are removed, preventing work loss. Why are the others incorrect? A. Non-preemptible workers are significantly more expensive than preemptible ones, which fails the requirement to minimize costs. B. Forceful decommissioning abruptly removes nodes without waiting for active tasks to finish, leading to the loss of work in progress. C. Cloud Stack Driver is not the appropriate tool for this purpose. Dataproc natively provides graceful decommissioning to securely preserve work on preemptible nodes.
You work for a shipping company that uses handheld scanners to read shipping labels. Your company has strict data privacy standards that require scanners to only transmit tracking numbers when events are sent to Kafka topics. A recent software update caused the scanners to accidentally transmit recipients' personally identifiable information, PII, to analytics systems, which violates user privacy rules. You want to quickly build a scalable solution using cloud-native managed services to prevent exposure of PII to the analytics systems. What should you do? The options are Option A, create an authorized view in BigQuery to restrict access to tables with sensitive data. Option B, install a third-party data validation tool on Compute Engine virtual machines to check the incoming data for sensitive information. Option C, use cloud logging to analyze the data passed through the total pipeline to identify transactions that may contain sensitive information. Option D, build a cloud function that reads the topics and makes a call to the Cloud Data Loss Prevention, Cloud DLP, API. Use the tagging and confidence levels to either pass or quarantine the data in a bucket for review.
To arrive at the correct answer, we focus on the keywords, Kafka topics, personally identifiable information, PII, scalable solution, cloud-native managed services, prevent exposure of PII.
The correct answer is option D, Build a cloud function that reads the topics and makes a call to the Cloud Data Loss Prevention Cloud DLP API. Use the tagging and confidence levels to either pass or quarantine the data in a bucket for review.
Why is this correct? D. Cloud functions provide a scalable, cloud-native way to process Kafka messages. Integrating with the Cloud DLP API effectively identifies and handles PII before it reaches analytics systems, directly addressing the requirement to prevent exposure using managed services. Why are the others incorrect? A. This secures data after it has reached BigQuery, failing to prevent PII exposure to other analytics systems downstream from Kafka, and does not actively identify PII in transit. B. Managing virtual machines and third-party tools is not a cloud-native managed service approach and requires significant operational overhead, reducing scalability. C. Cloud logging is used for analyzing logs, not for inline data inspection and redaction of messages in Kafka topics to prevent PII exposure.
You have developed 3 data processing jobs. One executes a cloud data flow pipeline that transforms data uploaded to cloud storage and writes results to BigQuery. The second ingests data from on-premises servers and uploads it to cloud storage. The third is a cloud data flow pipeline that gets information from third-party data providers and uploads the information to cloud storage. You need to be able to schedule and monitor the execution of these 3 workflows and manually execute them when needed. What should you do? The options are: Option A, create a direct acyclic graph in Cloud Composer to schedule and monitor the jobs. Option B, use Stackdriver monitoring and set up an alert with a webhook notification to trigger the jobs. Option C, develop an App Engine application to schedule and request the status of the jobs using GCP API calls. Option D, set up cron jobs in a Compute Engine instance to schedule and monitor the pipelines using GCP API calls.
To arrive at the correct answer, we focus on the keywords, schedule and monitor, workflows, manually execute them.
The correct answer is option A, create a direct acyclic graph in Cloud Composer to schedule and monitor the jobs.
Why is this correct? A. Cloud Composer, Apache Airflow, is Google Cloud's managed workflow orchestration service. It is specifically designed to author, schedule, and monitor complex data workflows via directed acyclic graphs, DAGs, and inherently supports manual execution. Why are the others incorrect? B. Stackdriver monitoring, cloud monitoring, is for alerting and monitoring infrastructure/application metrics. It is not an orchestration tool and cannot schedule or manage workflow dependencies. C. Building a custom App Engine application to schedule and monitor jobs requires significant, unnecessary development effort. Cloud Composer is a managed, purpose-built solution for this exact requirement. D. Managing cron jobs on Compute Engine requires manual infrastructure maintenance and lacks built-in dependency management, robust monitoring, and workflow visualization compared to Cloud Composer.
You have Cloud functions written in Node.js that pull messages from Cloud pub/sub and send the data to BigQuery. You observe that the message processing rate on the pub/sub topic is orders of magnitude higher than anticipated, but there is no error logged in Cloud logging. What are the 2 most likely causes of this problem? Choose 2. The options are: Option A, publisher throughput quota is too small. Option B, total outstanding messages exceed the 10 megabytes maximum. Option C, error handling in the subscriber code is not handling runtime errors properly. Option D, the subscriber code cannot keep up with the messages. Option E, the subscriber code does not acknowledge the messages that it pulls.
To arrive at the correct answer, we focus on the keywords. Message processing rate on the pub/sub topic is orders of magnitude higher than anticipated. No error logged in Cloud logging.
The correct answers are option C, error handling in the subscriber code is not handling runtime errors properly. And option E, the subscriber code does not acknowledge the messages that it pulls.
Why is this correct? C. Unhandled runtime errors can cause the cloud function to fail silently without acknowledging the message or logging the error, triggering continuous redelivery by pub/sub. E. Failing to acknowledge processed messages causes pub/sub to repeatedly redeliver them once the acknowledgement deadline expires, artificially inflating the apparent message processing rate. Why are the others incorrect? A. A small publisher throughput quota restricts the number of messages entering the topic, which would decrease the processing rate rather than increasing it. B. Exceeding the maximum outstanding messages relates to flow control. It pauses or throttles message pooling and would not cause an excessively high processing rate. D. If the subscriber cannot keep up, a backlog forms, and the processing rate would appear constrained or lower than expected, not orders of magnitude higher.
You are creating a new pipeline in Google Cloud to stream IoT data from Cloud Pub/Sub through Cloud Dataflow to BigQuery. While previewing the data, you notice that roughly 2% of the data appears to be corrupt. You need to modify the Cloud Dataflow pipeline to filter out this corrupt data. What should you do? The options are: Option A, add a side input that returns a boolean if the element is corrupt. Option B, add a Parto transform in Cloud Dataflow to discard corrupt elements. Option C, add a partition transform in Cloud Dataflow to separate valid data from corrupt data. Option D, add a group by key transform in Cloud Dataflow to group all of the valid data together and discard the rest.
To arrive at the correct answer, we focus on the keywords, modify the Cloud Dataflow pipeline, filter out this corrupt data.
The correct answer is option B, add a Parto transform in Cloud Dataflow to discard corrupt elements.
Why is this correct? B. A Parto transform is the standard Apache Beam operation for element-wise processing. It is ideal for filtering because it can evaluate each element and conditionally yield only the valid data, discarding corrupt elements efficiently. Why are the others incorrect? A. Side inputs are meant to inject additional, secondary data into a transform, not to return Boolean values to filter the main input collection. C. A partition transform splits the dataset into multiple output collections. While it separates the data, it does not explicitly discard the corrupt elements, making it more complex than necessary. D. Group by key is an aggregation operation used to group elements by a common key. It is highly inefficient and completely inappropriate for simple element-wise data filtering.
You have historical data covering the last 3 years in BigQuery and a data pipeline that delivers new data to BigQuery daily. You have noticed that when the data science team runs a query filtered on a date column and limited to 30-90 days of data, the query scans the entire table. You also noticed that your bill is increasing more quickly than you expected. You want to resolve the issue as cost-effectively as possible while maintaining the ability to conduct SQL queries. What should you do? The options are: Option A, recreate the tables using DDL. Partition the tables by a column containing a timestamp or date type. Option B, recommend that the data science team export the table to a CSV file on cloud storage and use Cloud Data Lab to explore the data by reading the files directly. Option C, modify your pipeline to maintain the last 30 to 90 days of data in one table and the longer history in a different table to minimize full table scans over the entire history. Option D, write an Apache Beam pipeline that creates a BigQuery table per day. Recommend that the data science team use wildcards on the table name suffixes to select the data they need.
To arrive at the correct answer, we focus on the keywords, filtered on a date column, scans the entire table, bill is increasing, cost effectively as possible, maintaining the ability to conduct SQL queries.
The correct answer is option A, recreate the tables using DDL. Partition the tables by a column containing a timestamp or date type.
Why is this correct? A. Partitioning the BigQuery table by a date or timestamp column restricts queries to scan only the relevant partitions instead of the entire table, drastically reducing costs and retaining standard SQL functionality. Why are the others incorrect? B. Exporting data to CSV on cloud storage abandons BigQuery's analytical power, disrupting standard SQL workflows and adding unnecessary data movement overhead. C. Splitting data into multiple tables increases pipeline complexity and forces users to rewrite queries or use unions, which is significantly harder to manage than native partitioning. D. Creating a separate table per day, sharding, is an outdated practice in BigQuery that degrades query performance and complicates schema management compared to partitioning.
You operate a logistics company, and you want to improve event delivery reliability for vehicle-based sensors. You operate small data centers around the world to capture these events, but leased lines that provide connectivity from your event collection infrastructure to your event processing infrastructure are unreliable, with unpredictable latency. You want to address this issue in the most cost-effective way. What should you do? The options are: Option A, deploy small Kafka clusters in your data centers to buffer events. Option B, have the data acquisition devices publish data to Cloud Pub/Sub. Option C, establish a cloud interconnect between all remote data centers and Google. Option D, write a cloud Dataflow pipeline that aggregates all data in session windows.
To arrive at the correct answer, we focus on the keywords: improve event delivery reliability, unreliable, with unpredictable latency, most cost-effective way.
The correct answer is option B, have the data acquisition devices publish data to Cloud Pub/Sub.
Why is this correct? B. Cloud Pub/Sub is a fully managed, global messaging service. Having devices publish directly to Pub/Sub bypasses the unreliable leased lines entirely, offering events reliably at the edge in the most cost-effective manner without infrastructure overhead. Why are the others incorrect? A. Deploying and maintaining small Kafka clusters globally introduces significant operational overhead and infrastructure costs, making it not the most cost-effective solution. C. Setting up cloud interconnect globally is extremely expensive and complex, directly contradicting the requirement for the most cost-effective way. D. Cloud Dataflow processes and aggregates data but does not resolve the underlying network unreliability or event delivery issues between the collection and processing infrastructures.
You are a retailer that wants to integrate your online sales capabilities with different in-home assistants, such as Google Home. You need to interpret customer voice commands and issue an order to the back-end systems. Which solutions should you choose? The options are: Option A, Speech-to-Text API. Option B, Cloud Natural Language API. Option C, Dialogflow Enterprise Edition. Option D, AutoML Natural Language.
To arrive at the correct answer, we focus on the keywords: in-home assistants, such as Google Home, interpret customer voice commands, issue an order to the back-end systems.
The correct answer is option C, Dialogflow Enterprise Edition.
Why is this correct? C. Dialogflow Enterprise Edition is specifically designed for building conversational interfaces. It provides built-in integration with Google Assistant, Google Home, intent recognition to interpret commands, and fulfillment features to issue orders to back-end systems. Why are the others incorrect? A. Speech-to-Text API only converts audio to text. It cannot interpret the intent of the voice command or issue orders to back-end systems. B. Cloud Natural Language API analyzes text for structure and meaning. It does not handle voice input or provide conversational logic and integrations for in-home assistants. D. AutoML Natural Language is used to train custom machine learning models for text classification or extraction, but it doesn't support conversational interfaces or voice command interpretation.
Your company has a hybrid cloud initiative. You have a complex data pipeline that moves data between cloud provider services and leverages services from each of the cloud providers. Which cloud-native service should you use to orchestrate the entire pipeline? The options are: Option A, Cloud Dataflow. Option B, Cloud Composer. Option C, Cloud Data Prep. Option D, Cloud Data Proc.
To arrive at the correct answer, we focus on the keywords hybrid cloud, complex data pipeline, orchestrate.
The correct answer is option B, Cloud Composer.
Why is this correct? B. Cloud Composer is a managed Apache Airflow service designed to author, schedule, and orchestrate complex workflows and data pipelines across hybrid and multi-cloud environments. Why are the others incorrect? A. Cloud Dataflow is meant for data processing, batch and stream, rather than orchestrating multi-cloud or hybrid workflows. C. Cloud Data Prep is a visual tool used for exploring, cleaning, and preparing data, not for pipeline orchestration. D. Cloud Data Proc is a managed Hadoop and Spark service for big data processing, not an orchestration service.
You use a dataset in BigQuery for analysis. You want to provide third-party companies with access to the same dataset. You need to keep the costs of data sharing low and ensure that the data is current. Which solution should you choose? The options are Option A, use Analytics Hub to control data access and provide third-party companies with access to the dataset. Option B, use Cloud Scheduler to export the data on a regular basis to cloud storage and provide third-party companies with access to the bucket. Option C, create a separate dataset in BigQuery that contains the relevant data to share and provide third-party companies with access to the new dataset. Option D, create a Dataflow job that reads the data in frequent time intervals and writes it to the relevant BigQuery dataset or cloud storage bucket for third-party companies to use.
To arrive at the correct answer, we focus on the keywords provide third-party companies with access, keep the costs of data sharing low, ensure that the data is current.
The correct answer is option A, use Analytics Hub to control data access and provide third-party companies with access to the dataset.
Why is this correct? A. Analytics Hub enables direct, secure data sharing across organizations without moving or copying data. This ensures the shared data is always current and avoids additional storage costs, meeting all requirements. Why are the others incorrect? B. Exporting data creates copies, incurring extra storage costs. Periodic exports also mean the shared data is not real-time, failing the requirement to ensure data is current. C. Duplicating data into a separate dataset incurs additional storage costs and requires a synchronization mechanism to keep it current, increasing complexity and cost. D. Using Dataflow for frequent data copying introduces significant processing and storage costs. It also adds unnecessary complexity and latency compared to native BigQuery sharing capabilities.
Your company is in the process of migrating its on-premises data warehousing solutions to BigQuery. The existing data warehouse uses trigger-based change data capture, CDC, to apply updates from multiple transactional database sources on a daily basis. With BigQuery, your company hopes to improve its handling of CDC so that changes to the source systems are available to query in BigQuery in near real-time using log-based CDC streams, while also optimizing for the performance of applying changes to the data warehouse. Which two steps should they take to ensure that changes are available in the BigQuery reporting table with minimal latency while reducing compute overhead? Choose 2. The options are Option A, perform a DML insert, update, or delete to replicate each individual CDC record in real time directly on the reporting table. Option B, insert each new CDC record and corresponding operation type to a staging table in real time. Option C, periodically delete outdated records from the reporting table. Option D, periodically use a DML merge to perform several DML insert, update, and delete operations at the same time on the reporting table. Option E, insert each new CDC record and corresponding operation type in real time to the reporting table, and use a materialized view to expose only the newest version of each unique record.
To arrive at the correct answer, we focus on the keywords near real-time using log-based CDC streams, optimizing for the performance of applying changes, minimal latency while reducing compute overhead.
The correct answers are Option B, Insert each new CDC record and corresponding operation type to a staging table in real time. And option D, periodically use a DML merge to perform several DML insert, update, and delete operations at the same time on the reporting table.
Why is this correct? B. Streaming CDC records into an append-only staging table enables near real-time data ingestion without encountering BigQuery's concurrent DML limits. D. Running a periodic DML merge applies the staged changes in bulk to the reporting table, optimizing performance and minimizing compute overhead. Why are the others incorrect? A. Executing individual DML statements per record in real time will quickly exhaust BigQuery's DML quotas and degrade system performance. C. Periodically deleting outdated records does not apply inserts or updates, making it an incomplete approach for handling CDC data. E. Appending all CDC records directly to the reporting table increases costs, and BigQuery materialized views have limited support for the window functions needed for deduplication.
You are designing a data processing pipeline. The pipeline must be able to scale automatically as load increases. Messages must be processed at least once and must be ordered within windows of 1 hour. How should you design the solution? The options are: Option A, use Apache Kafka for message ingestion and use Cloud Dataproc for streaming analysis. Option B, use Apache Kafka for message ingestion and use Cloud Dataflow for streaming analysis. Option C, use Cloud Pub/Sub for message ingestion and Cloud Dataproc for streaming analysis. Option D, use Cloud Pub/Sub for message ingestion and Cloud Dataflow for streaming analysis.
To arrive at the correct answer, we focus on the keywords: scale automatically, processed at least once, ordered within windows of 1 hour.
The correct answer is option D, use Cloud Pub/Sub for message ingestion and Cloud Dataflow for streaming analysis.
Why is this correct? D. Cloud Pub/Sub scales automatically and guarantees at least once delivery. Cloud Dataflow is a fully managed, auto-scaling stream processing service with robust native support for time-based windowing and ordering. Why are the others incorrect? A. Apache Kafka requires manual cluster management and does not scale automatically. Cloud Dataproc does not auto-scale as seamlessly as Dataflow and lacks its robust native time-based windowing capabilities. B. Apache Kafka does not scale automatically as load increases without manual intervention for cluster resizing and partition reallocation, violating the core requirement of automatic scaling. C. Cloud Pub/Sub is correct for ingestion. However, Cloud Dataproc processes data in microbatches, does not scale as effortlessly as Dataflow, and makes implementing 1 hour window ordering more complex.